Students, it is the first lecture of sampling technique of this week. स्टूडेंट्स ये लेक्चर मैंने पहले भी रिकॉर्ड किया था, लेकिन इसकी लेंथ ये तकरीबन 20 मिनट्स का लेक्चर था, लेकिन यूट्यूब पे अपलोड नहीं हो सका। लिहाजा मैं इसे दोबारा रिकॉर्ड कर रहा हूँ और कोशिश करूँगा कि ये 10 मिनट्स में वाइंड अप कर दूँ। इस साथ मैं PDF भी शेयर करूँगा, तो आप प्लीज़ यू ट्राई टू अंडरस्टैंड with this video lectures and along with its PDF document. Alternatively, here I shared application an example from a book, Advanced Sampling Theory with Application. The statement of example is John and Michael was appointed to select 3 players out of 5 players from the list of the players Amy, Bob, Chris, John and Eric with the scores in previous matches 125, 126, 128, 90 and 127 respectively. John considered the following sampling schemes consisting of only 4 possibilities: S1 Amy, Bob and Chris, and so on. S4 Amy, Don and Eric. The probabilities of these selection of these sample is given here. Each sample have 0.25 probability. Question is that find the part of the questions is that find first order inclusion probabilities for John sampling scheme. Find the estimate of the total score from each sample using John sampling scheme. C part, find the bias in John sampling scheme. D part, find the second order inclusion probability of John sampling scheme. E part, find the variance of the John sampling scheme using San, Yates and Grundy formula. Find the variance of the John sampling plan using usual formula. Find the variance of the John sampling plan using definition of variance. H part, are 3 variances are equal for John sampling scheme. Here I have also shared some written text about some another form of the formula for Hovitz Thompson estimator, and the same formula given by by San, Yates and Grundy formula. Another form of the variance of the estimator of population total by Hovitz Thompson is given as variance of y hat st is equal to sum of I belongs to capital omega. Capital omega is basically population values into 1 minus pi divided by pi into yi square plus sum of I varies from 1 to capital omega. Sum of j is not equal to I belongs to capital omega. Pi I j minus pi j divided by pi I into pi j divided into yi yj. Now come on the solution of these parts which I shared here. Now remaining part 2 and part 3 I will be shared in next lecture. For the time being, see the solution of first part of this question. These are the inclusion probabilities of first order calculated from the given sample. The sample S1 and S4 included ME in the sample. Therefore, we will calculate the probability of PS1 and probability of PS2, probability of S1 and S4, which is equal to 0.5. Similarly, we can find pi 2, pi 3 and pi 4. We have to check the person, the player has been included in the sample, and the and we'll take the sum of the probabilities of that samples. Now to estimate the total score based on the first, second, third and fourth sample is equal to sum of yi divided by pi I. Pi is the first order inclusion probabilities which have been calculated in part A. Me divided by pi 1 plus and so on, Chris divided by pi 2. Pi 1, pi 2 and pi 3 are the first order inclusion probabilities, and Me, Bob, Chris will replace by their respective scores. So after calculating these values, we obtained 672.66. Similarly, we have calculate y hat ST2 Jones. Jones means by using the Jones sampling technique. So it has become 542.66. 2 mean the second person. First we have calculate for Me, and second person is Bob. I think we have calculated for Bob, then for Chris, and then for John. Hope you have understand the calculation of inclusion probabilities and the respective scores by first, second, third and fourth sample. 1, 2, 3, 4 is represent the number of samples S1, S2, S3 and S4. The C part, the bias in Jones sampling scheme. Note that true total score of the 5 players is Y is equal to sum of I is sum 1 to 5 yi. Sum of all the players is equal to 596. Now the bias, the expected value of y hat st minus y. Y hat st will be calculated from the y hat Hovitz Thompson estimator of the population total, that is the total of score into their respective probabilities minus actual total of population total, that is y. After calculating these values, we have saw that the bias y hat st by using Jones sampling scheme is 0, so it is an unbiased estimator. Now D part, the second order inclusion probabilities. By 1 to it means first and second player has been included in the sample. The sample which have Amy and Bob player in the sample, it is only S1. S1 sample have Bob and Amy as player. So the probability of S1 is equal to 0.25. Similarly, you find pi 1 2, pi 1 3, pi 1 4 and so on, pi 3 5, pi 4 5. Now come on E part, the variance of Jones sampling plan using San, Yates and Grundy formula, which is given here. In this equation, by opening this equation, we have this expression. By replacing the respective values from in this expression, we have variance of y hat st by San, Yates and Grundy method is equal to 3035.33. Similarly, variance of y hat st by using Jones sampling techniques, it is Hovitz Thompson formula. Now by replacing the respective values, opening this formula and by replacing the respective values in this formula, we have 3035.33. Variance by definition, that is sum of I is from 1 to 4 PST y hat st by using Jones sampling technique minus y whole square, replacing the respective values in this formula. we have 3035.33. Therefore, variance of Whitehead HT by using John sampling scheme by San, Yates and Grandi is equal to variance of Whitehead HT by using John sampling technique, and variance by definition Whitehead HT is equal to John's R3R equals